Hello and welcome dear students. I am Shravan Kumawat, your maths lecturer. Today we will start with the next subtopic of mathematical logic, that is rules of negation. In rules of negation we will face two types of statements. First one is simple statement and next is compound statement. So let us first see the rules for simple statement. Simple statements. In simple statements, suppose we have the words all or every. Then while writing the negation of simple statement, then these words are replaced by the word some. These words are replaced by the word some, and some is replaced by all and every. For example, all students are hardworking. All students are hardworking. So here we have to write the negation of this statement. So simply negation of means what? Denial of this statement. So here we have to make this, we have to convert this positive sentence into negative. But here we have to replace the word all also by the word of some. So here we will replace the word all by what? The word some. So here we write some students are, negation compulsory we have to write, not we have to compulsory insert in the sentence. We have all some students are not hardworking. So this is logically negative sentence. All students are hardworking. The negation of that statement is what? Some students are not hardworking. Next rule is what? Suppose we have the word quantifiers. There exist. Then there exist quantifier is replaced by for all, and for all quantifier is replaced by what? There exists. For example, there exists x belongs to n such that x plus 2 is equal to 7. There exists x belongs to n, here n is set of natural number such that x plus 2 is equal to 7. So what is the negation of this statement? Here you have to replace this existential quantifier by what? Universal quantifier. So write here universal quantifier x belong to n, and while writing negation such that what is replaced, so here x plus 2 is not equal to 7. Equal to, the negation of equal to is what? Not equal to. So for all you have will only comma, and for existential quantifier with existential quantifier you will have comma as well as such that. So while writing the negation, suppose we have the next statement, for all x belong to n, x plus 1 is equal to 7. Then x plus 1 is equal to 7. So what is the negation of this statement? While writing the negation, you have to replace these two symbols. There exists x belongs to n such that what it will be also there with comma for existential quantifier. With existential quantifier you will have comma as well as such that, and with universal quantifier you will have only comma such that x plus 1 is not equal to 7. So these are the rules for what? Simple statement. So let us write the rules for what? Compound statement. Suppose we have compound statements. So rules for compound statement is what? First rule is what? First rule, negation of conjunction. Negation of conjunction. Conjunction means what? And. Suppose we have statement P and Q, and we have to write the negation of this compound statement P and Q. Then simply we will write negation of P or negation of Q. This is also known as what? De Morgan's law. Second is what? Negation of disjunction. Negation of disjunction. Negation of disjunction or negation of P or Q. Simply we write negation of P and negation of Q. So first statement negation of conjunction and negation of disjunction. These two statements are also known as what? De Morgan's law. Now let us write third, involution of or negation of negation. Negation of negation. This is also known as negation of negation is also known as what? Involution law. So here if we have negation, and we have to write negation of negation, then simply we will write what? P only. So third rule, negation of negation is also known as what? Involution law. Fourth rule is what? Suppose we have P implies Q and we have to write the negation of this statement. So as we know, P implies Q can also be written as using conditional law, negation of P or Q. Negation of P or Q. So use De Morgan's law here. So you will get negation gets cancelled, P, and you have to replace or by and negation of Q. So this is the negation of what? P implies Q. So directly if you write P implies Q, negation of P implies Q, then it is P and negation of Q. Fifth rule is what? P double implies Q. P double implies Q. So what is P double implies Q? P double implies Q, we can write what? First we write P implies Q and Q implies P. P implies Q and Q implies P. So use your De Morgan's law. So you will write this as P implies Q or, and you have to replace by what? Or, and negation of Q implies P. Now use your conditional law, break P implies Q into what? Negation of P or Q. So if you break P implies Q into negation of P or Q or negation of Q or P, then again use De Morgan's law, then this is what? P replace or by and negation of Q, P and negation of Q or Q and negation of P. So directly this is the rule for finding negation of P double implies Q, P and negation of Q or Q and negation of P. So these are the 5 rules for finding negation of 5 compound statement. First rule is what? Negation of conjunction. In negation of conjunction, P and Q. So while writing negation of P and Q, you have to write the individually negation of P and negation of Q and convert and into what? Or. This law is also known as what? De Morgan's law. Next is what? Negation of disjunction. Disjunction means what? Or. Suppose we have P or Q, then simply we write we have to write the negation of P and replace or by and negation of Q. So statement 1 and 2 are known as what? De Morgan's law. They are also known as what? De Morgan's law. Third statement is what? Negation of negation. Suppose we have statement negation of P and we have to write negation of that statement also. So negation of negation P is what? Simply P. This is also known as what? Involution law. This is also known as what? Involution law. Next statement, fourth one is what? P implies Q. So directly you can learn P implies Q. Negation of P implies Q is what? P and negation of Q. P and negation of Q. Fifth is what? P double implies Q. The negation of P double implies Q is what? P and Q. P and negation of Q or Q and negation of P. So let us see the examples based on these 5 rules. Write the negation of following statement patterns. Suppose we have to write the negation of P or Q and P and negation of Q. Here we have to write the negation of this statement. So write the entire negation, take the entire negation of this statement, negation of P or Q and P and negation of Q. So first use De Morgan's law. Consider these two statements as individual statement P and Q. So write negation of these two statements, negation of P or Q and is replaced by the connective or, negation of P and negation of Q. So use again De Morgan's law, negation gets cancelled, P or is replaced by and, P and negation of Q or, here negation of P or Q. This is the negation of P or Q and P and negation of Q. So with this we have completed the topic rules of negation for simple statements as well as for compound statements. Thank you.